Good day, everyone, and we once again meet to discuss physical science. And as we've been looking at the November 2020 paper in preparation, for those final exams, which of course many of you will be writing very soon. Okay, so if you're not part of the family, if you haven't subscribed, please just add to our numbers and just make sure that we keep growing. And for those of you who need assistance with mathematics or physical science, you're more than welcome to send us an email, and our email address is info@mlungisinkosi.co.za. All right, so I'm going to be looking at work, energy, and power. All right, quite an interesting question, and I've been receiving quite a lot of requests asking for me to go through this question. Well, finally, the moment is here, right? Okay, so let's look at it together. So they give us a roller coaster car, right, of mass 200 kgs with an engine switched off, okay, that travels along track ABC. Okay, so there's our track there. They say it has which has a rough surface, right, as shown in the diagram below. They said point A, which is 10 meters above the ground, the speed of the car is 4 meters per second, so there it is there. And then at point B, which is at a height h, so we don't know that height over there. Okay, they say the speed of the car is 2 meters per second. Okay, they say during the motion from point A to point B, okay, they say 3.4 times 10 to the power 3 joules of energy is used to overcome friction. Okay, they say ignore the rotational effects due to the wheels of the car. Now, the first thing that we look at, they say define the term non-conservative force, right? Please remember we say that non-conservative forces are forces whose work done depends on the path taken. Okay, so essentially it means that those forces actually depend on the the path that is taken. If you think about it, friction depends on the path. It means if you're moving in one direction, friction goes the other, whereas gravitational force, which is a conservative force, it doesn't matter where you go, gravity actually acts in the same direction. The work done by gravity is always downwards. Okay, right, so they say calculate the change in the kinetic energy of the car after it has traveled from point A to point B. Now, want to note the change of that kinetic energy, right? Now, we keep in mind that they told us that there's work done by the frictional force, or rather to overcome friction, right, which is a non-conservative force. So in this case, what I'm going to do is let me use that principle over there, right? In fact, why do I even want to complicate my life? We've got the velocity there, we've got the velocity over there. So the change in kinetic energy is going to simply be, okay, so that's 5.2. So our change in kinetic energy, going to say change in kinetic energy is going to be kinetic energy final, which is at B. Okay, so I'm going to say EK at B minus the initial kinetic energy, okay, which is at A, right? So I know this is going to be half of m VB squared minus half m VA squared. Okay, if you wanted to, you can take out the half m as a common factor, all right, and just okay, so this is going to be half the mass of the trolley, okay, was given as 200 kilograms. Okay, the final velocity that is at B, that's 2 squared, right, minus half of the mass, again 200 times the initial velocity, which was at that point there, that's 4 squared. And all that we need to do, just press our calculator, and our final answer becomes minus 1200. So you can put that in your calculator and check, verify if that is true. Okay, so in this case, that's the change in kinetic energy. And of course, don't be alarmed by the fact that that change is negative. The reason for that is that kinetic energy final is less than the initial kinetic energy. So, of course, it does mean that you've lost some of that kinetic energy there. Okay, right. The next question, they want us to calculate the, they say use energy principles to calculate the height h. Right. Now, obviously, we want to try and use as much as possible because this is where we've got the most information, isn't it? Okay, so remember we were given that work done, okay, due to overcome friction. So let me use the principles of energy. Okay, I'm going to say, well, the work done by non-conservative forces is equal to the change in kinetic energy plus the change in potential energy. Now, please, I want you to stay with me. Right, so obviously in the roller coaster, when we talk about non-conservative forces, all right, and I want you to, I know this may sound simplistic, but I promise you this works. So for those who don't know what I'm talking about, please go and watch our videos on work, energy, and power. So we say that the work done by non-conservative forces would be work done by the applied force as well as the frictional force, right? So there was no applied force, so in that case there's no work done by applied force, but we do have work done by friction. So this is going to be the work done to overcome friction. And I want you to always remember this amount of work done obviously should be negative because you're basically losing energy, right? Just like we did here, we were losing kinetic energy as well as here, you're losing energy to try and overcome friction. Okay, so we had a change in kinetic energy there and a change in potential energy. Okay, let me just write that quickly. So in this case, we know this value here was given as 3.4 times 10 to the power 3 joules. But remember, as I indicated to you, this should be energy that is lost to the system, isn't it? Okay, and we were given that kinetic energy there as minus 1,200 that was lost. Okay, and the change in potential energy. Now, please, I want you to stay with me here. So it means that it's going to be potential energy final, okay, minus the potential energy initial. So I'm going to say it's mass times gravitational acceleration times the change in height, okay, to get that height there. So it's going to be the mass, which is 200 times 9.8 multiplied by, now if you think about it, would have said final minus initial. So my final height is h, but what about my initial height? My initial height was 10. Okay, right, and of course you could have expanded this, okay, but ultimately we get to the same place. All right, now let's try and work out and just do our mathematical gymnastics. So of course you take this to the other side, it becomes positive. Okay, and then of course we're going to divide by that 200 times 9.8 and add the 10, and let's see what we get for our final answer, right? So if I take this to the other side, I end up with minus 2,200. Okay, and I'm going to divide by that, so I'll be left, okay, let's just divide by 200 over 200 times 9.8. okay, so I'm left with h minus 10. Okay, if I calculate that, I get a negative 1.12 meters, which is h minus 10, and of course we want the height h, and in this case I'm going to get, okay, let's add 10 to that. Okay, right, I get a height of 8.8, well, you can say 8.88, okay, meters. I'm going to round it off to 2 decimal places as per the examiner's instructions. Yeah, so hopefully that makes sense. So that's the height that we find at position B, right? Okay, I hope that made sense to you. Right, let's get to the next question. They say on reaching point B, the car's engine is switched on, right? So now this tells you that we're going to have work done by the engine of the car. It's an applied force, okay? So they say the car's engine is switched on in order to move up the incline to point C, which is over there, okay, which is 22 meters above the ground. So while moving from point B to point C, the car travels for 5 seconds at a constant speed. Okay, so that's very important. There's no change in kinetic energy, while an average frictional force of 50 Newton acts on it. Okay, so they want to find out, they say calculate the power delivered by the engine, okay, to move the car from point B to C, right? Now, if you don't mind, I'm just going to just move this so that I create some space for myself. All right, so if we look at this question, I can use the same principle, work done by non-conservative forces again, right? So I can say, well, work done by non-conservative forces, remember we say changes kinetic energy plus it changes potential energy. Now, the reason why I'm going this route is that, remember, how do you calculate power, right? So power, sorry about that, okay, so power is the change in energy divided by the change. Yeah, it's basically the rate at which work is done. Power is energy divided by time. So if I can find out how much work is done by the engine of the car, I can divide by the time that is given there and obviously find the power there. But in this case, let's find out first of all, how would I be able to calculate the work done by the engine of the car, right? So remember, we can say, well, it's the work done by the engine plus the work done by friction. Okay, they did say there is frictional force there, right? Frictional force of 50 newtons. Okay, so let's find out now. This would be equal to the change in kinetic energy. Now, there wouldn't be a change in kinetic energy here because kinetic energy here and there should exactly be the same. So you should have that as 0 plus the change in potential energy. Of course, we can find that out, isn't it? Okay. And the change in kinetic energy should be my mass. Okay, once again, it's going to be potential energy final. Okay, which is obviously when it gets to that minus potential energy initial. So that would be final minus initial. So that's a change in potential energy. So now you're going to have to make just a couple of plans here, and please just stay with me. Remember, this is where we are trying to get to, right? Want to find out the work done by the engine, okay? But what is the work done by friction? We know this is always going to be force times displacement multiplied by the cos of the angle theta. Okay, we'll come back to the frictional force because you can see we were given the frictional force there. All right, plus in this case our potential energy final, it's that potential energy there. So I'm just going to say 200 multiplied by 9.8. If you don't mind, I'm just going to take the difference in our potential energy. So that's 22 minus, remember that value that we obtained there, which is 8.88, right? So our final is 22 and our initial was 8.88 meters, right? Now, okay, and this is where we are trying to get to. Now, as I said, we're going to get to, of course, trying to make a plan around this, okay? Yeah, we can calculate 200 times that. But let's first talk about this frictional force. We know the value of our frictional force is 50 newtons, right? Now the issue here was, okay, now how do we obtain the displacement or the, the distance there? And well, it's as simple as this. We know the velocity, right? And we know the time that it took to get to point C. So we can use equations of motion. Askis, I'm going to actually take a detour a little bit. Okay, so we can use equations of motion and say, well, delta y, remember that what do they call it? The velocity is constant. So that means that there's no acceleration, right? So that's half at squared, okay, at delta t squared. But remember, because the acceleration is constant, the velocity is constant, it means our acceleration is 0. So of course that falls away, right? So in this case, we said our velocity is 2 and our time is 5. So it means that displacement there should be 10 meters. So it means it was displaced between B and C, it was displaced 10 meters. So I'm going to take that. Remember now when I take it to the other side, okay, you know what? Maybe let me not make it confusing. Let me just keep it there. So that's 50, okay, plus 50 times the displacement, which is 10, okay, the cos of. Now, please remember, in this case, when you look at direction of motion, that's upwards, but the frictional force is acting down the incline, so it's going to be the cos of 180, and all of this is equal to that product. I might as well just find it so that we don't waste our time. So that's 9.8 into, that's 22 minus 8.88, okay. So I get a value of 25,715.2 for this product over here. So of course we can take this to the other side. So the work done by the engine, okay, I hope I didn't confuse you in any way. So the work done by the engine of the car, right, is going to be that value. Now note this value over here, cos of 180 makes this guy negative, so that's 50 times 10, which is 500. Cos of 180, that's negative 500. So I take it to the other side, of course it becomes positive. So I'm going to just add 500 to that. Okay, and you can verify these values just to check if I'm still doing the right thing. So this is the work done by the engine of the car. But remember, what did we want? Wanted to find out the power, okay, done by the engine. So power is the rate at which work is done. So work done by the engine divided by time. And so we're going to take that value 26215.2 divided by the time that it took, which was 5 seconds. And in this case, we get a value of, okay, I get a power of 5,243.04. And remember, power is measured in watts. Okay, right. Could there have been another way to do this? Okay, perhaps we can look at it. Okay, so my suggestion is that perhaps you could have found the force that is applied by the engine of the car. Now, if you didn't know, please note that power is also measured by the product of a force. Now, because we're looking for the power of the engine, right, it means you're going to look at the force of the engine multiplied by the constant velocity in this case. So you can find the power that is exerted by the engine. Okay, suppose you could have used the work energy theorem in that case, yeah, to find the net force. And finding the net force, you can now find the force that's exerted by the engine of the car, and thereafter, multiply that with the velocity. You can try it out and see if you get to the same place. All right, and yeah, that is how the cookie crumbles, right? And I hope that you understood this question. Yeah, quite a bit of a tricky one there, but nonetheless, we we've got this, right? I know you've got this. So I hope you enjoyed it, and I'll see you guys next time. Please don't forget to subscribe and tell even more people about our channel, and we keep growing. Okay, see you next time. Ciao.